Welcome back to Introduction to Symbolic Logic. This is Lecture 5. Today we are going to do two main things. I want to discuss with you two exercises that are going to allow us to put together some of the main skills that we have acquired over the course of the last couple of weeks. And then I will going to offer you a study guide for exam 1 and discuss what the main concepts are that you should review and the main exercises that you should go over to be best prepared for the first exam. So the first thing on our agenda today are two exercises that are going to allow us to put together some of the main skills that we have acquired. And these exercises are going to concern the assessment of arguments. Here's the first example. Consider the following argument. If Dorothy plays the piano in the morning, then Roger wakes up cranky. Dorothy plays the piano in the morning unless she is distracted. So if Roger does not wake up cranky, then Dorothy must be distracted. We said that one of the main tasks of logicians is to evaluate the quality of arguments. And we also said that one of the main virtues that we are looking for is validity. A good argument is valid. So what we are going to do here is we are going to look at this argument and assess its validity. And we are going to do that in two steps. First, we are going to find a symbolization of this argument in TFL, and then we are going to construct a truth table that will allow us to see whether this argument is in fact valid. So let's start by symbolizing our argument. The first step in the symbolization process is to paraphrase the argument in a way that makes its logical structure transparent. Now, the argument that we started out with here already had a pretty transparent structure, and I didn't need to do much in order to make the structure more transparent. So I only did two main things. First, I separated out the three sentences in our argument, just to remind myself that we have three claims that are being made. And then the last sentence used the word so, which is a conclusion indicator, which told me that the last sentence is the conclusion. And I replaced this word so by means of the three dots that represent a conclusion indicator. And then the conclusion included the word not. It said, if Roger does not wake up cranky. And I know that this stands for a negation, and so I chose to move this word not in front of the sentence Roger wakes up cranky, using the phrase it is not the case that, in order to remind myself that here we have a negation that I am going to represent by means of the negation operator. So those were the two main things that I did to paraphrase the argument in order to make its logical structure more transparent. The second step in the symbolization process is to identify the atomic sentences and to provide a symbolization key for these atomic sentences. So let's see, what are the atomic sentences in this example? The atomic sentences, as you may recall, are the smallest units of language that can be evaluated for truth and falsity. In this case here, we have at least three different atomic sentences. Let's see what they are. First, I see that we got the sentence, Dorothy plays the piano in the morning, which looks like an atomic sentence. And I see that this sentence appears twice, so I'm going to mark it in green on both occasions. That is one atomic sentence. Dorothy plays the piano in the morning. Now, the second atomic sentence that I'm noticing here is Roger wakes up cranky. And this sentence also appears twice. It appears in the first line, and then it appears in our conclusion. Roger wakes up cranky. And then we have a third atomic sentence, which is the sentence, Dorothy is distracted, or Dorothy must be distracted. She is distracted. She must be distracted. I'm going to treat that here as the same sentence. Okay, so we have identified the atomic sentences, Next, let's introduce a symbolization key. So how am I going to symbolize these three sentences? I'm going to choose the capital letter A to symbolize the sentence, Dorothy plays the piano in the morning. And I'm going to use the capital letter B to symbolize the sentence, Roger wakes up cranky. And I'm going to use the capital letter C to symbolize the sentence, Dorothy is distracted. Okay, step done. Step 2 is done. We have identified the atomic sentences and provided a symbolization key. Let's move on to step 3, in which we are going to identify the Boolean connectives. So in the first premise, I see the words if, then, and I know that these English words represent a conditional, which I'm going to symbolize by means of this arrow. And then in the second line, I see the word unless, and I know that I can symbolize that by means of the disjunction sign. And then in the last line, I again see the words if, then, which I'm going to symbolize by means of this conditional arrow. And I see the words, it is not the case that, and I know that's a negation sign. Okay, that's it. We have identified the Boolean connectives. Now in the last step, we are just going to move on and symbolize the whole argument. So how does that go? Well, premise 1 is if A, then B. Premise 2 is A or C. And the conclusion is if it's not the case that B, then C. That's it. We have symbolized our argument and will be able in the next step to assess its validity using a truth table. Let's see how we can use a truth table to assess the validity of our argument. So the argument has two premises, if A then B and A or C, and the conclusion is if it's not the case that B, then C. Now I'll just add a little exclamation mark on top of my conclusion here just to remind myself that this is the conclusion of my argument. I've already constructed the reference column for this argument. We have 3 atomic sentences, A, B, and C, and a truth table with 3 atomic sentences is always going to have 8 rows as I have constructed them here. So all we need to do is fill in the columns in our assessment column to the right. Let's start with the first premise, if A, then B. Now, a conditional if A then B is false in only one case. It's false when A is true and B is false. So let's see. In the first row, this is true, true, false, because we have this F and this T. True, true, false. Again, we have an F, a T, and an F. True, and true. Okay, so that's the assessment column for our first premise, which is a conditional. Let's move on to the second premise, if A or C. Now that's a disjunction, and a disjunction is true if either one of the two disjuncts is true. So let's see. In the first row, this is true, since both are true. True, 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 given that C is true. True, true, and then false and false. So the second premise is only false in the last 2 rows of the truth table, since in those 2 rows both A and C are false. Now let's look at the conclusion. Here we have a conditional. The antecedent of the conditional is not B, and the consequent of the conditional is C. So let's first assess not B, the antecedent of our conditional. The negation sign flips the truth value of B, so that's going to be F, F, T, F, T, T, F, and T. And then the truth value of our conditional is going to depend on the truth value of the antecedent. So I have to look at this column here, and on the truth value of the consequent. So I also have to look at this column here. And as before, the conditional is false in only one case, namely when the antecedent is true and the consequent is false. So that means it's true in the first row since the antecedent is false. And in the third row, it's also true since both antecedent and consequent are true. Here it's true since the antecedent is false. True since both antecedent and consequent are true. Now in this row here, the conditional is false since the antecedent is true, but the consequent is false. And then the conditional is true again and false again. Okay, so that's our completed truth table for the entire argument. Let's next see how we can use this truth table to assess whether our argument is valid. So we need to look at, obviously, the two columns for our premises, and then we need to look at the column under the main connective of our conclusion, which is this column here. And this argument is valid if and only if in every row where both premises are true, the conclusion is true as well. So what are these rows? Well, I see in the first row both premises are true, in the second row both premises are true, and then in the fourth row again, in the fifth row, and that's it. So we need to look at the first two and at the fourth and at the fifth row. Now what's the truth value of our conclusion in these rows? Here we have a T, a T, a T, and a T. Okay, awesome. So that means our argument is in fact valid, given that the conclusion is true on every valuation that makes both premises true.